Now, so start back a little bit. This is one thylakoid. This is inside the chloroplasm. Out here, that's the stroma, also shown here as the chloroplasm. Inside here is the thylakoid space. So light hit both photosystem, photosystem 1 as well as photosystem 2. But we're going to start telling you the story from photosystem 2 first. So light hits photosystem 2. Now, this is the place where the photolysis that we talked about before, the photolysis where the cell uses the light energy to split the water molecule. So to split the water molecule, the light gets these electrons excited. It has a lot of energy. So these electrons, high energy electrons, get passed down this electron transport chain. So this is like mitochondria. This is also an electron transport chain. Now when they pass these electrons down, they will pump the protons from the stroma or the chloroplasm into the thylakoid space. Also at the same time, because of photolysis, now you have these extra protons floating in this thylakoid space also. So electrons go down this electron transport chain, protons get pumped in to the thylakoid space, gets passed down, past the cytochrome complex, past the photosystem 1, again more light hitting the photosystem. These electrons get energized again, go down here, go to this NADP reductase. Now, you remember from before, when something gets reduced, you gain electrons, but in biology, not only electrons, you also gain hydrogen. So that is the reason why NADP plus becomes NADPH. Okay. So the electron transport chain goes down here, pumps protons from the stroma or chloroplasm into the thylakoid space and at the NADP reductase and create a NADPH. So now you have this high energy molecule that will go to fuel the Calvin cycle. At the same time, because of these pumping as well as the water getting split, you have lots of hydrogen ion or protons inside the thylakoid space. You have a high concentration of protons inside the thylakoid space. You have a low concentration of hydrogen in this area here in stroma. So in this case, it flows through this ATP synthase. Again, you see a similar structure in the HL respiration. So this high concentration of protons flows back out to the stroma through the ATP synthase. And ATP synthase is an enzyme that synthesizes ATP, so you have more ATP. Okay? So both of these processes generates high energy molecules that will power the Calvin cycle, the light independent reaction.